Chapter 11?
Yes.
Gases. It's a gas.
Warm.
We're going to talk about drinking soda first. Where I grew up, we called it pop, but here mostly people call it soda. So in the book, the author talks about how when he was a kid, he liked to make extra long straws at the fast food restaurant. Did you guys actually read the chapter? Did you know you're supposed to read the chapter before you come to class?
I haven't looked at those. Kind of like it after.
And we're going to talk about orange soda, and I see that you have orange soda, so good job being in theme for the chapter. You must have read ahead, right? So he liked to stick the straws together, and then he'd like to stand on his chair and put the soda on the floor and drink through the straw, right? And you can imagine his parents just really loved that. But, he's a future scientist, and so he's wondering, how long could I make the straw? Could it be infinitely long and you could still suck soda up the straw? So how actually does a straw work? Have you ever thought about that? So here's a picture of a kid, and he's made a long straw. So when you suck on the straw, initially there's some air in the straw, and you're sucking those air molecules out of the straw and creating a lower pressure. And then the soda comes up in the straw, right? Why does the soda come up?
There's less air pressure pushing down into it?
Well, there's atmospheric pressure pushing down on the soda, and it's actually the pressure of the atmosphere pushing down on the soda that pushes it up when you lower the pressure in the straw.
Makes sense.
And so you could not make an infinitely long straw that would work. Even if it had perfect seals, because when you just jam straws together, they leak a little bit. Even if it was one long continuous piece and didn't leak, and even if it wouldn't collapse on itself, like they do sometimes when you're sucking too hard on them to get the Jack-in-the-Box milkshake up because they're too thick, right? It's like, I don't want to wait for it to melt a little bit. That's what spoons are for. Even if you had a perfect vacuum and the thing didn't collapse, you still could not suck up soda higher than about 10.3 meters in a straw. Now that is about 34 feet, so that's pretty impressive. But you could not stand on top of this building and drink soda out of a cup on the ground. It would not work, okay? The soda will not rise higher than 34 feet. It just won't.
Was this tried?
I'm sure it has been tried.
That's a funny problem.
Yeah, I'm sure it has. So why is this? Why is this? Well, there is pressure exerted by the gas particles. And so here, if we're looking at this, here we have gas particles in the air, and they're just zinging around, and sometimes they hit the surface of the liquid, and they exert a pressure. Pressure is defined as force per unit area. At sea level, there's atmospheric pressure from the atmosphere hitting things, and that pressure is measured, it can be measured in different ways. 101,325 newtons per square meter, that probably doesn't make much sense to you, or 14.7 pounds per square inch, which another abbreviation for that is PSI, and you've probably heard of that. If you've ever inflated tires, that's the unit we use in inflating tires. So the pressure of the atmosphere is 14.7 PSI. When you suck on a straw, initially when you put the straw into the soda, what happens? The soda goes into the straw, right? And the level of the soda inside and outside is the same. Because the pressure of the atmosphere pushing down on the outside and on the inside is the same. When you suck on the straw and you remove some of that air, you reduce the pressure inside. And so it's not pushing down as hard, but it's still pushing down the same on the outside. So the atmosphere pushing down on the soda pushes the soda up into the straw. But it can only push the soda up so far. So if you have an extra long straw, here's an illustration. Here we have a vacuum pump. and a tube here, and if you had a perfect vacuum here, there's nothing there, absolutely nothing, perfect vacuum, you could only suck the soda would only rise 10.3 meters. Because the force that the atmosphere pushes down on that will only support that height of water, of soda. Yeah, because gravity is pulling the soda down, and so the atmospheric pressure is pushing it up.
So it equalizes itself.
So it equalizes, yes.
The diameter of the straw doesn't make a difference?
The diameter of the straw doesn't make a difference, strangely enough. Yes.
Is this based on, like, if you're at sea level, or is this?
This would be at sea level,
Okay.
yeah.
So it might be a little higher if it was, like, below sea level, or?
It would be a little higher if you were below sea level, and if you were much above sea level, it would be significantly lower. So the soda will rise only until the pressure exerted by its weight equals the pressure exerted by the atmosphere pushing down on the rest of the soda. Okay? So you can go home and say, hey, I learned how straws work today. And they're like, you didn't know that before? No, really, I learned how they actually work.